So, hi, and thanks for being here. I am Niels Leenheer, and I created HTML5 Test. That's a website for testing web standards. And I'd love to tell you about all kinds of useful details and about standards and about browsers. And we have already seen some really amazing and especially useful talks. So, in the interest of balance, I'm not going to talk about standards, APIs or browsers. No, I'm going to talk about my new house. It's a parish house. I moved there about 6 months ago, and on this photograph it actually looks a lot better than it actually is, because there's a road right between there, and it's from 1779, so it's an old, creaky house, and it takes a lot of work to modernize it, to bring it into the future, like an internet connection. So I live in this small village that actually has really fast internet. And the network, the cable network was built in the last century, well, 1990s. But when they reached our house, the reverend that lived at the house said, well, no, I don't want any television. But the cable company, they put a street cabinet right in my own yard, so I'm actually just 10 meters away from fast internet. I can see it right out of my window of my office. But those last few meters, that seem like an insurmountable obstacle. So I'm from the Netherlands, and in the 80s we had this television show. It was hosted by Tealight, and it was called De Wondere Wereld. And that's actually difficult to translate because it's somewhere in the middle of a wonderful world or a wandering world. And I used to love this show because it was about technology, it was about the future. The host of this show had this project. It was called the House of the Future, and it was actually built. And as a child, I visited this house, and I was amazed by it. And it pioneered all kinds of new technologies, like speech control, and HD TV, and teleshopping, and telebanking. It also featured some failures, like CDI, interactive CDs, and digital compact cassettes, but also pioneered sustainable building and separating waste and solar panels. So nowadays, many of those things have become reality. You can literally buy in the store and use in your own home. Radio-controlled switches that have been really common, and you can find them anywhere from many vendors, and these are really cheap. But also smart lighting, like the U. You can turn on and off lights using your phone or using your voice, like Siri or Alexa or Google Assistant. Wi-Fi connected speakers, which you can place throughout your house. And all of these things wouldn't be out of place in the house of the future. But still, I miss something. And maybe it's that feeling of bewilderment of the past. So everything is possible nowadays. And everything is so useful. And everything is so boring. But you can combine these devices to build something bigger, to connect them together, to let them do things they couldn't do on their own. To do that, I use a Raspberry Pi with domotic software running on it, and it basically, you have all your devices in one place, allowing you to control them through a simple web interface. And using domotics, you can combine the devices and build things like a chicken thermostat. Yes, chickens also get cold. Seriously. When I moved into my new house, I inherited a total of 5 chickens from the previous owner, and now I need to take care of them. And that includes, in the winter, going outside and checking their water didn't freeze. And I don't like that. It's cold, and I am, well, lazy. So I created an overly complicated system to solve a really simple problem. We need a kippenwaterdrinkbak, or watertrouw, obviously. And kippenwaterdrinkbak verwarmingselement to heat the water in the trough. And like I said, I am lazy. I don't want to go outside to turn on the heater, so we need a kippenwaterdrink verwarmingselement schakelaar to switch the heater on and off remotely. And to know when we want to do that, we need a kippenwaterdrink verwarmingselement schakelaar thermometer, which measures the temperature. And to combine all of those, we have a FXCOM. So the temperature sends a ping every 30 seconds with temperature using 833 megahertz radio signal. And the FXCOM decodes that signal and sends it to domotics. In domotics, you can use a very simple scripting language. Well, scripting, it's called Blockly. You just drag and drop blocks, and you can do something with that temperature. In this case, if the temperature is below 0, turn on the heater. And that means domotics uses the FXCOM to send a radio signal to the switch, and the switch turns on. And you can do all kinds of other stuff, like sending notifications to make sure your heater is turned off, and it does not burn down the chicken run. So this is all fun. But this is all completely insecure. Just radio signals sent openly over the air, and anyone can pick up and imitate them. That means I can see all of the switches of my neighbors, and all the motion sensors, and all the wireless doorbells. And I can, well, activate my neighbor's fire alarm in the middle of the night, repeatedly, if I wanted to. So these are all the sensors in my neighborhood. Nowadays, we have to deal with this kind of stuff, with botnets of webcams and worms in your lighting and stuff like that. So I decided to have fun with this. Combining existing things is fun, but building your own stuff is even more fun. So this is the fiery witch's kettle. This is do-it-yourself IoT. And to do that, we need a brain, a microcontroller. There are different options. You could use Arduino, for example. It's quite big, it's limited, almost no memory and very little processing power. Well, doesn't even have a normal operating system, but you can write code that runs straight on the processor. But it isn't network connected, and that kind of defeats the purpose for a connected device. So that's kind of useless here. So there is this Wi-Fi module. It's really small. It's for the Arduino, and it's an ESP8266 chip. When it was released on the market, it just has Chinese documentation. So using Google Translate and a lot of hacking, some smart people found a way to load their own custom firmware and to run actual code on this Wi-Fi chip. So you don't even need the Arduino anymore. And this is the Node MCU. It's a little bit bigger, and it embeds one of those ESP chips. And it adds a really an easy USB connector and some pins to connect to other devices or sensors. And it's an open source design, and it's very cheap. A local store in my neighborhood sells them for about 10 euros each, but if you order them from China, you can find them for 3 or 4 euros. So I bought a whole bunch of them because I'm not an electrical engineer, so I already blew up a few of those, just crossed the wrong pins and a puff of smoke, and it doesn't work anymore. But if you're not like me, one will do. It comes with firmware that can run Lua scripts, but you can also use the Arduino SDK and write code in C. So the first thing I tried is to connect it to a NeoPixel ring. And it contains 24 individual LEDs that you can turn on and off individually. And the code to turn on one of those pixels is actually not that difficult. You just initialize the NeoPixel library and set a brightness and set a pixel color. Just that simple. You could do some more stuff, like creating a ring that turns clockwise. Kind of looks like this. Just gonna plug it in. That's it. Just that little piece of code. And of course, you're not C developers, you're all web developers, but JavaScript and C, that's kind of the same thing. Well, just about. Okay, not really, but the syntax is quite similar, and everybody who knows JavaScript can learn C. So the project I created was Tealight, the witch's kettle. So I bought this at IKEA, and I thought, why not make a Wi-Fi connected Tealight? Because, well, you can. And it's completely useless, and I love it. So what I did is I added an extra hole for the USB cable. I placed the LED ring on the bottom, and I connected the Node MCU. And a small plastic tube around it, which I brought in a do-it-yourself store. And finally, a plastic cap. And it looks like this. I can show you here too. It tries to connect to the Wi-Fi now, but I'm not at home, so can't find the network. So it's red. And now it starts sparkling. So it's actually pretty realistic. And I heard last week from my neighbor that he once woke up in the middle of the night and saw this flickering light coming from my house. And he thought my house was on fire. And he was about to jump the fence, and when he noticed it wasn't really quite natural, and then he saw the light and the lamp, and well. So adding Wi-Fi must be really complicated. At least that's what I thought. This is how you do it. This is all the code to set up Wi-Fi and a basic web server. And you can add some extra code to turn the lights actually on and off, because nowadays this is just an empty stub. So this is the API I created, power, on, off, status, brightness, and you can change the color. And then I hooked it up to my existing IoT infrastructure, like Apple HomeKit. And you can use the Home app on your iPhone to turn on and off your Tealight. Siri is possible. Just turn the sparkle off, and it's off. Or Alexa or Google Assistant. It's all possible. I thought this was really fun, but I want to do something extra. Do something more, like monsters. So the second project I worked on is a pixel art display. And you may have already noticed the display over there. I'll just pick it up. It can show monsters. It can also show notifications, but mostly monsters. So I like to procrastinate.
a lot. And drawing monsters is much more fun than doing actual work. So basically, this is just a ceiling light I bought in a do-it-yourself store, and I ripped out its guts, which is rubbish, and then added a Node MCU and an 8x8 LED panel. Added some wires, some components, an SD card for storage of monsters, a buzzer for notifications, a light-resistive sensor to make sure it doesn't flood the whole room with a green light in the middle of the night. And this is how it looks. I'm sorry, maybe in the back, you can't really see it, and it's actually not working anymore. Ah, it's there. It's very small. I looked into making a bigger version using U-lamps, but that would have cost 3,500 euros, so that's kind of expensive. And also a practical problem, you can't take the big one with you on a plane. So this is how it looks. I didn't like the round pixels created by the LED elements, so I tried 3D printing to create a matrix that you can place in front of the LED panel. So we have this wonderful fab lab in the area where you can use all these devices like laser cutters and 3D printers to create real physical things, often just for free or just the material cost. And after some mishaps, okay, a lot of mishaps, I finally got this. It's a nice matrix. It fits right on top of the LED panel, but it didn't work very well. The original white version leaked light from one pixel to another, and I created a black version that fixed that, but 3D printers can be very rough, so the pixels were irregular or uneven. So how to fix this? Well, of course, lasers. But that also has its challenges. This wooden matrix actually caught fire right after I took this picture. But finally, the last iteration, a black plexiglass matrix with the LED panel right behind it. And it looks pretty good, I think. I'm still working on a custom enclosure, but that's something I want to work on in the future. But I didn't only work on the matrix. I actually ditched the SD card. I replaced it, the sensor board with actual components, then a soldered breadboard for better reliability, reduced size, making a custom PCB, which is very easy nowadays. Download some software, Fritzing, and draw it, and order it online. And 2 weeks later, you have a custom PCB. And then I created the second revision that sandwiches all the components right between the PCB and the Node MCU. And so it now looks a lot more professional. It's sadly so. This is also necessary if you want to take it with you on a plane, because, yeah. So this is the final result. This actually runs a web server, and it runs a WebSocket server, and it has firmware that contains HTML, JavaScript, and CSS, and it can connect to a Wi-Fi network, and then you have a progressive web app right there on the Node MCU. So you can simply open it on your phone, add it to the home screen, and then open it, and it works like this. You just use your fingers to draw and select colors. You can just draw monsters. So, how does this work? actually not really new technologies. Tomorrow we're going to hear a talk about IoT in the browser, which uses all kinds of difficult or new APIs. This is, compared to that at least, very simple. This is just touch events. And I look at the change touches array and make sure we have support for more than just one finger. And then I get the right table cell from the document using element from point, because this is just an 8x8 table. And then set the background color of the table cell to the current color, and use a WebSocket to talk to the pixel display and send a draw command, the X and the Y coordinates, and a color. And to me, it's amazing that the little piece of hardware, like the Node MCU, is so powerful to run a WebSocket server, and you can actually talk to it in real time from the browser. So there it goes to the display. And it's actually so powerful, you can connect multiple devices to it at the same time. So the draw command is then sent back to all the connected devices. And there it goes. And so this device receives the same draw command, finds the right table cell, sets the background color, and that's it. So I'm now going to try a demo. And there are at least 5 different things that can go horribly wrong with this, so this feels like tempting the demo gods. So let's take a moment. Breathe in, breathe out. OK. The demo. I have a phone. I'm trying. To connect it. It never works the first time. There it goes. Phew. So I can start a web app. It takes a while, probably because of all the Wi-Fi signals. It really takes a while. Let's try it one more time. There it is. Again, phew. So, kind of works. There's a bit of a delay, but OK. OK, I pushed the random button, but you get the idea. So, the mystery of the haunted mailbox. Ooh. So this sounds like the title of an old Scooby-Doo animation. But it's actually something that happened to me. I have this mailbox. It's all the way outside of my yard and outside of my view, and I want to know when my mail arrives. And like I said before, I'm really, really lazy. And walking out to my mailbox every couple of hours to check if the mail is there is hard work. So, of course, you can create a really complicated solution to solve this really simple problem by using magnetic contacts. And every time the lid of the mailbox opens, it sends a radio signal. It's picked up again by the RFXCOM and handled by Domotics, which can call an API to the pixel display to let me know the mailbox has been opened. And it looks like this. And I also get a notification on my phone and my watch. It's not annoying at all. So during Christmas dinner last year, I suddenly got dozens of notifications. On, and the pixel display kept beeping, and my phone buzzing, and I had no idea what was going on. And the problem went away as quickly as it started, and about a month later, I noticed the same thing happening again. So what was the problem? Was my mailbox haunted? Well, it was during the day, so I could see what was going on. During strong westerly winds, the mailbox blows open. Okay, how are we going to solve this? Well, you combine the magnetic sensor with a motion sensor. That should work. But even during westerly winds, people walk by, so a lot of false positives. Just turn off the magnetic contact with strong westerly winds. I have a weather station, so that's possible. Then again, mail will also be delivered while the wind is blowing, so that's also not really a good solution. So sometimes you don't need a really complicated solution at all. Just literally some little padding to prevent the lid from opening. And that worked, and the problem hasn't returned since. So this is just a lot of fun. Well, at least it's for me. I had a lot of fun making this. I love just tinkering with hardware and trying to build geeky stuff. Having fun for me is basically the most important thing you can do with technology. So I want to say thank you.